All right, welcome. So in this video, I want to continue talking about drawing to the canvas, but now what I want to do is build a class that will programmatically find and select the correct frame of an animation to paint to the screen so that we can animate Mario. Now, luckily this original Mario, most of the animations are actually single frame animations, which means most of animating Mario has to deal with moving from one state to the next. For instance, maybe moving from the state of ducking to the state of jumping. Okay, ducking to jumping, or maybe running or walking to idle, or idle to running. Now the one animation, or there's a couple here, there's the swimming, but the one I'm going to focus on is the walking or running animation. The only difference between walking and running in the original Super Mario Brothers is just the speed of the animation, which is, there's lots of real cool and clever ways that the original Super Mario Brothers were able to do a lot with a little, and in this case a lot of cool animations and effects with little bit of memory. There was a very little amount of memory on those original NES cartridges. But in this case, I'm going to focus on the walk animation. That is a 3-frame animation. But as you can see on this Sprite sheet, there are many of them. There's small walking to the right, large walking to the right, Fireball Mario walking to the right, and then the same 3 animations walking to the left as well. So I want to set up a class that isn't just set up for one of these animations, but it should work for all of these animations, and indeed should work for the swimming animations, and even should work for some of the single frame animations in here as well, because I'm going to want all of these to be set up with a single class called, in my case, an animator. So here I have my animator class, and what I'm going to do in my animator class is I'm going to pick out those frames that I want to animate, or that I want to draw right now, and then I'm going to call my draw image in the same way we just looked at in that last video, calling it with this prototype where I say where from the original sprite sheet I want to draw from, and then I'll just draw it into the proper location on the screen, on the canvas. Now I want to go through a couple steps here. There's really only 2 things that we need to do in this class, and it's technically in this one method that we're going to do it, which is 1, determine what frame are we on, and then 2, paint that frame. So first step, do a little bit of logic, figure out what frame are we on, and then 2, once we have it, find it and paint it. Now to put this together, our animation is going to need a lot of different information. Let's take a look at this quickly. I think a lot of this is going to look familiar because it's the same information we probably would want for our draw image method that we're going to call down in a second. First of all, we need an image. So our animator is going to take an image in its constructor. For the most part, it's not going to do anything with this image other than store it and pass it on and use it down below here when we actually call draw image. So it really just holds on to it. What else does the animator do? Well, we want to tell the animator where in this image, in this sprite sheet, does our animation start. And usually that means by telling it what the first frame of the animation is going to be. So I'm going to pick the X start and XY, which is the XY of my start frame. Again, following the pattern we saw in the last video, the XY here should be the top left corner of that start frame. And not surprisingly, the next 2 are going to be the width and the height of that particular frame. What other information might we need? How many frames are there? That's what the frame count's going to be. So my simple walk animation is a 3-frame animation. This is going to tell us that there are 3 frames. The frame duration tells us how long should each frame be on painted on the canvas before we switch to the next frame. Now this will help us speed up or slow down our animation. Now notice this is just happens to be something Seth Ladd chose to do, and I've done it as well. We could have also, instead of used the total time here, how long do you want the whole animation to last? I think frame duration works out well. One way or the other, we calculate the total time down below here by taking the frame count and multiplying it by the frame duration. So if you give us the total time, we could calculate the frame duration, or vice versa. How you want to do it is up to you. Following Seth Ladd's example, I've decided to use frame duration to tell me how long each frame is on the screen. And then this is special. This is a unique one, or special one, because this sprite sheet that I have here is used in a couple of interesting ways. There's some padding between my images, or maybe between, you know, frame 1 and frame 2. There's some empty white space here, and the amount of white space actually changes, and that's because our Fireball Mario needs an extra frame for shooting a fireball. Our small Mario and large Mario don't need that. And so the padding between these frames down below is smaller than the padding between these frames up above. And I guess whoever made this sprite sheet, you know, some unnamed anonymous internet user who I borrowed it off of some Mario website, they decided that this was convenient for their animation. Now what I could have done is change this sprite sheet so that it had no padding. That's usually easier to animate if there's none of this white space between the different frames. And a lot of the sprite sheets you'll find out there will be that way, with none of the padding. I could have edited this in Photoshop or something, eliminated those extra pixels, but I decided it's actually easier for me to just build this into my code. So what I decided was add this frame padding here, which will tell me how much padding there are between frames. So I'll just skip over that padding when I go fetch the next frame. And of course, if there is no padding, if I happen to use this Animator class for a sprite sheet that has no padding at all, I'll just set this to 0. The last two are going to be Boolean input, reverse and loop, and they're just going to tell me if this animation should run in reverse or it should loop, or maybe both, if they're both set to true. Now, why did I have to do this? One main reason is because with this sprite sheet, just again, the way that anonymous user happened to build this, we have the right hand going out to the right here, and the left hand going out to the left here. Maybe the way they built this was just by building the right hand side and then doing a mirror image flip over there. That would be easy. And now we've got animations going out to the left. But the way my animator is going to work is I'm going to pick my first frame to be the leftmost one and then go 1, 2, 3. And then that way, if I did it for this animation, it will be 1. So if I do for my left animation, I'll do 1, 2, 3 as my frames. That's actually going to make it look like Mario's walking backwards. And if I do it while he's walking forwards, he's going to look like he's moonwalking or something. Okay, that's going to look a little bizarre. So we're probably not going to want that. We're going to want to fix that. Okay, and we can test that out in a second. And so to do that, I've built in the ability to do a reverse on my animator as well. Okay, I can both reverse and loop. Now loop is because, well, once I've done 3 animations of my walk, 3 steps of my walk, I want to start back at the beginning again. The walking animation is a looping animation, and a lot of Mario's animations are looping animations. And a lot of the animations in a game are looping animations, but occasionally there are some, like maybe a jump animation, that when it's done, you've landed and that's it. You don't want to do it again. Or maybe a shooting animation. You shoot once, you don't want to keep doing it afterwards. Once you've done the shooting animation, you're done. Or more like a fighting game where you have a punch animation or a kick animation, something like that. Again, you press the button once, you only want it to do once, and then you want to return back to another state, idling or whatever else you're doing. Okay, so my constructor, I've sort of explained a little bit about all of these parameters, but all I really do with these parameters is I store them. So this object.assign just stores all of those parameters as local variables inside my object. And I create 2 extra local variables here. I already talked about calculating total time, but elapsed time is just going to keep track of how much time it's been that this animation has been running. And you can probably already anticipate here the interplay between elapsed time, total time, and frame duration is how we're going to determine what frame we're on. So let's go ahead and jump down here and take a look. This is a simple helper function that's been written by Seth Ladd that just is going to tell us our current frame. I should be clear here, this is with zero-based indexing, because as is true in a lot of cases, zero-based indexing makes our math work better here. So what we're going to do is we're going to take the elapsed time, however much time we've been animating. We're going to divide it by the frame duration, and that will tell us how many frames have gone by to get to this point. Now we want an integer, so we're going to throw this through the math.floor, and that's what's going to give us the zero-based indexing as well. So if we happen to be at elapsed time 0, we're right at the beginning of the animation, and we divide this out, we'll get 0, and so that will give us frame 0, which should be the first one. Okay. Now, the only extra piece of math that I think we need to do here is, so we can see here that this frame here is going to tell us, it's going to call current frame to select frame. I'm going to skip over some of the extra bit for a second, and just, where do we use frame here? We use frame exactly here in this calculation of the X index, or the X pixel in my sprite sheet. Now X start, remember, was the starting pixel of the top left pixel of the first frame. So when frame is 0, this 0 times does nothing, and we get what we expect, that first frame. Okay, we're also using this .y start, but it doesn't change at all. Why doesn't it change? Because all of the frames for one of my animations all appear on the same row. If they didn't appear on the same row, we might need to do changes here as well. But since they appear all on the same row, we just need to know where in that row we're going, and that's the X coordinate. Now imagine the frame is 1. If the frame is 1, that's now the second frame, technically, with zero-based indexing. Then we're going to take that original frame's location and add on to it, move over to the right. By how much? By the width of the frame plus the width of the padding, the extra padding that we have there. Okay, we take that, multiply by how many frames we need to shift over, and we're now on top of the frame we want to be on. Okay, again, we can see that this seems to work out logically the way we expect. What else is going on in our draw image method call? Not much else. As I already mentioned, the this.y start is the same. The width and the height is going to be the same. I've built into it a scale, which is, if I want to, when I call DrawFrame, when I call this animation DrawFrame and ask it to actually animate, I can tell it to draw it bigger or smaller, and that will make it bigger or smaller. Now, since I'm using the same width and height in these two entries here, that means I'm maintaining the same ratio of my width towards my height. What else do we have here is I've just got an extra little calculation or logic here to take care of looping and reversing. So this little bit here is, if my loop is done, meaning we've gone past the total time, we can see down below that all that is done does is check if elapsed time is greater than or equal to total time. So if we're done, then if we're also looping, we will loop back to the beginning. So I subtract off the total time, which will put me back to what original frame at the beginning. This is sort of like doing a mod operation in some sense, where I'm going to truncate off that extra bit and figure out what frame should I be on now. I've also added a logic here to return if I'm not looping. Now, my code never triggers this line. I could leave this out, and you could leave this out if you want, but I put a warning here in this video that if you do use this code and your code triggers this line, what that means is you're calling DrawFrame on an animation that's finished. And since this line is going to return, it's not going to draw anything at all. You're going to end up getting nothing drawn. You're going to get a flicker. You're going to get something that maybe should be drawing a frame but isn't. And if you get that error, well, I'm going to say, well, why are you calling DrawFrame on an animation that is already done? You probably shouldn't do that. So I never get to this line. I've left it in there. It's sort of an artifact of an earlier version of my code. But if you happen to hit this line and are getting a flicker, try and stop yourself. Stop yourself from entering that code at all. The last thing was the reverse, or the other thing I mentioned was the reverse. I skipped over this line because all I do in the case of reverse is I just calculate a new frame. If I'm actually on frame 0, which is the first frame, then I should be on the last frame, which would be this frame count -1, -0, -1. And vice versa. If I'm actually on frame 1, which is the second frame, I should be on the second to last frame, and so on. So this calculation just flips my frames around to figure out what frame I'm on. And that handles my reverse. This handled my looping. And the only other thing I guess I skipped over was the first thing we do in DrawFrame when we call it is we advance our elapsed time by 1 tick, whatever the tick is. Okay, now I say whatever the tick is, and maybe this is an important time for us to say, well, what is the tick? The tick is what I'm passing in here, and instead of trying to trace this back, I'm going to tell you exactly what it is. The tick is 1 tick of the timer. So the timer in our game is fairly simple. It's going to keep track of how much game time is passed. It's going to keep track of the last time we updated, the last tick. And it's going to do a little bit of error checking for us to make sure that we don't make too large of a jump. And those too large of a jumps could happen in the case of an error, or maybe in the case where we've tabbed out for a little bit and we had to go write an email and we're coming back to our game and we don't want it to say, well, you were gone for 5 minutes, so now you've been bombarded by 700 fireballs, you're dead. We want to say, no, it's only advanced by this small sliver of amount, which in this case is about 1/20th of a second. Now, how does this timer work? It's very straightforward and simple. All we're going to be doing is keeping track of how much time it's been since the last time we kept track of how much time it's been. So right now we need to really keep track of 2 things, the time right now and the last time. So up above here, I've already got my last timestamp initialized. So right now when we call tick, we're going to ask the timer, what time is it now, or how long has it been since the last time we called tick? So we call tick, and the first thing it does is says, well, what time is it now? So date.now returns the current time in milliseconds. Okay, so what we can do here is what this next line is going to do is try and calculate the delta, which remember Greek letter delta is usually used for a difference. So that's why Seth Ladd has used the delta here as the difference calculation, the difference between what? The current time, the time right now, and the last time we did this. So take the current time minus off the last time we did this, and since we work a little bit better in seconds than in milliseconds, I'm going to divide this by 1,000, which gives us how many seconds it's been since the last time we did this. Now, of course, it's probably not even been a full second since the last time we did this, so this will probably be a small number like 0.015 or something like that. But I'm going to keep it in seconds because my brain operates better in seconds than in ticks or milliseconds. Then we update the last timestamp to be current again. So now that we've updated this again, now the current time is the last time. So that next time we're ready to go. And then we really just return that difference, but here's that little error checking that I mentioned. We're just going to make sure that the sliver of time we've had here isn't too big. If it's too big, we'll truncate it down. We'll just take the minimum of these 2 values, and we will advance our game time by that amount and return the delta, return the difference. We don't return the current game time. That's not usually helpful for any of our calculations. What is helpful is how long has it been since our last update. So remember, when we get to our animation, we just want to know if I'm supposed to be showing this frame, say, for a second, then I want to know how long has it been. And then when I get over that boundary, that 1 second boundary, boom, I'll flip to the new frame. Okay, so that's where we're using that tick. So I want to try this out. Let's see if we can animate our Mario. So I'm going to just make a this.animation for now. And I'm going to make a new animator. And I'll just try and follow my method here. So I'm going to do a this.sprite sheet, which will be the current sprite sheet. Now, my X and my Y is the location on the sprite sheet that I want to animate. Now, I don't really know what they are, so let's go ahead and check. I think I'm going to do this one. Mario walking to the right. 239.52 looks like the values that I want. So my guess here at least was 239.52. And remember, I now need my width, which is 16, and my height, which was 32. The next variable coming up is frame count. Well, we had 3 frames. Now, how long do I want them to be on the screen? Now, this depends. I might need to balance this, tweak this number a little bit. But usually when I'm starting out my animators like this, I'm going to pick 1. Now, why 1? Actually, okay, let's go a little bit smaller than that, 0.5. I want it to be kind of slow. Why? If there's an error or a bug or something, I've messed up something, it's easier to see what that error is if your animation's running slow. And then of course, when you're done and you've got it working right, just come in here and pump this up to a faster value. Okay. Now frame padding, actually I don't know if I checked that earlier, but I'm cheating because I've done this before. I know the frame padding is 14. Remember, that's the amount of white space or empty space between my two frames. So I'm going to skip over that. And then I need to know, should I reverse? Well, this was not a reverse, so I'm going to do a false for my reverse. But my walking animation should be a loop, so I'm going to make that a true. That's hopefully going to create the animation for me. I'm going to delete my draw image here, and instead I'm going to do a this.animation.drawFrame. And what does it take? Well, it takes the clock tick. Now, I haven't really mentioned where the clock tick exists, so let's jump back here. And I think in my game engine video, I mentioned that in the loop, what I do is the first thing we do in our loop is we go and we call tick on our timer, right? Remember, that tells us how long it's been since the last time. And we store it in this variable called clock tick. Okay, now this is so that anything that needs this in this current update, so the next thing we do is call update, and all of our things get to update or draw. Any of those methods in their update and draw that need the clock tick can just go and fetch this variable and know how long it's been. So we're going to go here and do that. We need to know what the tick is, and to be able to fetch it, we're going to do this.game, that's the game engine, and then clock tick is the variable name. Now we pass in the context, that's the context we want to draw to, and the XY. Well, let's just put it at 0, 0 for now. And then also any scaling. I mentioned earlier that 3 times as big is how big I've been drawing things to make it a little bit easier to see. So let's try that, see if it works. Now this looks like Mario walking. Now the one thing I mentioned is the reason I put it on a little bit slower is it helps us see. It kind of looks like Mario's walking backwards. I'm not certain. It kind of looks like he's walking backwards to me. Now, I say it kind of looks like that because the original Mario is really bizarre. 3 frames is very small. 4, it's actually missing a frame here. Even when he's walking forward, he looks a little bit bizarre if you stare at him closely. But let's just go and see. Let's see. I've got my reverse here. Let's put him in reverse. Now he kind of looks like he is walking forward. Well, I don't know about you. It still looks a little bit bizarre, but he kind of looks like he's walking forward. So I've actually got my settings to this to be his forward walking animation. And it looks kind of normal when I play with him. So I think it's correct, but I probably need to speed it up a little bit. And actually the only difference I have between my run and my walk is how fast they go. Now I've actually got this version here from an earlier build of mine. I'm going to maybe go ahead and revert this a little bit by deleting out the animation I just built, because I've actually set up my animations for Mario a little bit more in depth here. I've created up several animators. This is an earlier version. Like I said, I didn't have all the versions of Mario animated here, but I've chosen to put my animations into arrays of animations that are indexed both by Mario's size, so is he little, big, or super, or is he, and which way is he facing, right or left? Okay, and I could have put another dimension on my array for the state, but I decided to just give them names like idle animation, walk animation, jump animation, and so on. I don't think I had initialized run animations yet in this case, but my run again is just my walk at a faster speed. So I set them all up, and I was actually just trying to test them all in this original build. I was just testing them all. So instead of drawing them all on top of each other here, I drew them all in different locations on the screen just to test them all out. So let's see what we get here. So I only had drawn them twice as big as they normally are here, and we can see our left-facing ones, our right-facing ones, our skidding, and our idle. I hadn't done jump yet, but jump is also a one-frame animation. So this is how I've set up my animations and organized my animations in Mario. And I think in the next video, I'll just show you how I can build up an animation for one of my enemies, in this case, the Koopa. So that's it for this video. So thanks a lot for watching, and I'll see you in the next video.